Now that we know how we can find the inverse and the determinant of a matrix, and in case you don't get what I'm talking about, I suggest you checking out the previous video on finding the inverse and determinant. Now we will finally get to use matrices to solve systems of linear equations. So what are systems of linear equations? Well, basically you've probably learned of it or heard of it before as simultaneous equation. Let's say we have an equation 4x plus 10y equals to 40, and we have x plus 5y equals to 2. Now obviously you could definitely use simultaneous equation to solve, but there are some equations that will be a bit more complex, right? So what we are going to do today is to use matrices to solve equations like this. Okay, so in this case, how do we use matrices to solve equations like this? Pretty simple actually. Now for this equation, how we will use matrices in this way. First, we take the coefficient of the x, which is 4, and 4x is 4, 1, this is x, so it's 1. Then we take the coefficient of the second variable, which for y is 10, and for y is 5, right? And then we align it as first variable x, y, another matrix, and finally equal to 40 and 2. Right, now what we want to do is we call this A, matrix A, this is matrix X, this is matrix B. Now when we want to solve for x and y, it's pretty simple. So we move A to the other side, and thus we get x equals inverse of A, B. Now, how do we find inverse? As we have learned, the inverse, A inverse, is equals to 1 divided the determinant of A multiplied by the matrix D negative B negative C A. This is how you find. So now let us find A inverse. So A inverse is 1 over determinant of A is basically in this case AD minus BC minus BC D negative B negative C A. I'll do it step by step so you get to follow. 1 divided by AD minus BC. AD is 4 times 5. 4 times 5 minus 10 times 1. D is 5. Negative B negative 10. Negative C negative 1. A is 4. What you get? You get 1 over 10 multiplied by 5, negative 10, negative 1, 4. Right, and then that is your A inverse. Now x equals to A inverse B, remember? So let me simplify. Okay, so you get, after multiplying with scalars, 5 over 10 is 1 half, negative 10 over 10 negative 1, negative 1 over 10 negative 1 over 10, 4 over 10 is, let me just double confirm, 2 over 5. Now we have to multiply by B, right? So A inverse B. So what we get is 1 half, negative 1 over 10, 2 over 5, multiplied by B. What is B? 40 and 2. Okay, following the matrix multiplication, let me do it on this side here, right? So I'm kind of running out of space. I'll do it here, right? So remember that to multiply, we take the first row, multiply the second column, first row multiply the column, second row multiply the column. So I mean, to verify, remember that we have to have the same. Okay, this is the 2 by 2 matrix and this is the 2 by 1 matrix. So for the first matrix, the column is the same as the row of the first matrix, so can multiply, right? Of course, here, let me show the working clearer. 1/2 multiplied by 40 plus -1 multiplied by 2, and for the bottom one, -1/10 multiplied by 40 plus 2/5 multiplied by 2. So just to highlight, I take this, multiply by this, and then we take this, multiply by this, and then we take this, multiply by this, and then finally this, multiply by this. Yes. Because row, column, always remember this, right? And what you get? Get 18. -16/5. And if you just, and this is your answer for x, and this is your answer for y. And if you check it out, if you input it, let's say for 18 and 10, -16/5, you can check your answer. For 18 plus 10, -16/5, you will get 40. Same apply for this one. 18 plus 5, -16/5, you will get 2. And that is your answer. Right? So moving on to more practice question. We have the equation -2x plus 6y equals 4, 5x plus y equals 6. Now we want to make it into matrix form. -2, 5 for x, 6 and 1 for y. Then we get xy equal to 4 and 6. Right, now we move it over. Remember, label this as A, A, X, and B. And then we want to find X equal to A inverse of B. Right? Inverse of AB. Okay, multiply by B. Right. Now, inverse of A equal to 1 over the determinant of A multiplied by D, -B, -C, A, equal 1 over determinant of A, -2, multiplied by 1 minus 6 multiplied by 5, D, 1, -B, -6, -C, -5, A is -2. But we get 1 over -32, 1, -6, -5, -2. We get -1 over 32, -6, 3 over 16, 5 over 32, (1 over 16). And then we take A inverse 1B equal to multiplied by b 4 times 6. Remember, this is negative 1 over 32 multiplied by 6, multiplied by 4 plus 3 over 16 multiplied by 6, 5 over 32 multiplied by 4 plus 1 over 16 multiplied by 6. You can input this into your calculator and you will find your answer. You should be able to find your answer. 1 get 1. So therefore x equals 1 and y equals to 1. If you try it, if you try to input negative 2, 1 plus 6, 1 equal to 4, and that is correct. 5 multiplied by 1 plus 1 equal to 6, and that is correct as well. And that is how you verify your answer, alright? Now, I may be running out of space, so I'll just try to move this part over a bit. Alright. Let me continue to solve another one for you. I suggest you try it out yourself first, by the way, before we go it through together. But anyways, let's continue. For A, you get the coefficient of A, we get 1, negative 3. B, we get 1, negative 2 for B. A, B. Just so you know, it works for every other variable. So regardless it's A, B, x1, x2, it doesn't matter. Label this as AX, B. And then, since we want to find the inverse of A, equal to 1 over the determinant of A, 1 multiplied negative 2 minus 1 multiplied negative 3, D negative B, negative B, negative positive, so negative C, negative 3, and A is 1. Okay, let's go. 1 over 1, negative 2, negative 1, 3, 1. And therefore, your A inverse on B. In this case, let me try to partition, just in case you guys don't get confused. Alright, negative 1B equals to, since 1 multiplied the matrix here is the same, so I'll just take it negative 1, negative 2, negative 1, 3, negative 1 multiplied by negative 4 and 14. You will get negative 2 multiplied negative 4 plus negative 1 multiplied 14, 3 multiplied negative 4 plus 1 multiplied 14. And what is your answer? You will get negative 6. And here is 2. And this is your answer for A, this is your answer for B. Right? And if you can just check it out, so if A is negative 6 plus 2 equals negative 4. Right? And then negative 3, negative 6 minus 2, 2 equal 14. And that's how you verify your answer is correct. And that's it for how we can solve using this is what we call the adjoint method. In the following video, we'll be going over Cramer's rule to solve a 2x2 matrices. Make sure to check that one out.